Hey, so what's going on, guys? So in this video I am going to show you how to do Juniper labs with logical systems. So, and as part of my JNCIP service provider exam, today we are going to do OSPF. So I have created this topology ahead of time, draw it somewhere, and this is what we are going to do. So the first thing, let's add a node. I'm using EventG Pro. Yeah, this is the VMX that I'm looking for, and I need to bump the interfaces to 12. Let's just call these Junos. Oops, call this Junos. And I'm going to save. I only need one node because I will be creating like 10 logical systems on that node. And then I'm going to interconnect those logical systems. So here I'm going to need this node right here. It's a network. Let's change the icon. I can call this .1q because again, this node type is bridge, and by default it supports 802.1q. So the EventG team has done a pretty good job at doing that, so I don't have to mess around with switches. And while what I need to do is just so the EventG team has done a pretty good job to create this, so I don't have to mess around with switches, while my primary goal here is to do routing, so I don't have to kind of struggling with VLANs and doing 802.1q, because this guy over here is going to do that on my behalf. So again, let's look at the topology. As you can see here, I have these routers, 10 routers, and I have assigned on every router, I am going to assign one interface. Basically not one interface, but the logical interface of one interface. For example, if you look at R1, I am assigning Gigi 001, but only the units. For example, VLAN 119 will be used here. So let's do this. Let's connect our switch to the router. This is how much interfaces I have. Basically, I am going to connect all my gig interfaces to the switch. Again, you don't have to watch me do all that, so I'll pause the video, and when I'm done. So I have connected all my gig ports to the bridge, as you can see here. Now, the next thing we are going to do is I am going to incorporate this picture into my EventG so that I don't have to look at this creepy topology. So let's right click, and do you see this? I'm going to add a picture, And remember, this picture has to be in a PNG format. So let's browse. As you can see, I have created this picture right here. I'm going to select and say open. Let's call this lab OSPF. Yeah, OSPF. That's fine. So as soon as I click add, you will see on the left side there will be a picture icon will be added here. Let's do that, and there we go. It's a logical map, as you can see here. So let's go over to that picture, and I'm going to click it. You see that? Nice, right? Okay, so let's map our underlay topology with the picture, so I don't have to go back and look at it. My creepy topology. So this is the edit button. Let's create. Oops, it looks so big. But anyways, if you look down here, you will see that if I would have had many nodes, they will be all listed here. So since I only have one node, in that one node, I'm going to divide it to like 10 nodes. So I am going to map this one node into all my routers. So I'll start here, 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 to all my devices. Let's move over here. I'm going to do okay, and there we go. Then I'm going to click save. Nice. So I will go back to my topology and let's start this router. And of course, to prevent this from moving around, let's just lock it so it doesn't have to move. If you go back to the logical map, open the picture, you'll see if I point to this node, you'll see like there is a difference, like it's an active node. So let's click here on R1. You see immediately it is going to open the underlay topology. So I'm gonna wait until this guy boots up, and then I'll come back and we're gonna configure this bad boy. Okay, so this bad boy has booted up. Let's log in with user root CLI configure. So here you can see we need to set the root password before we continue, because it's not gonna let us commit anything if we don't set up a root password. So set system root password, plain text password, set a password, and let's system login user. I'm going to create user my name. It's gonna be a class of super user, authentication, plain text password. Oops. And of course, I'm going to say set system, the host name. Let's just call it a Junos. Doesn't hurt. Oops. Let's do commit and quit. Exit. I'm going to log in with my name. There we go. Now, once you have done that, now we are ready to start configuring our logical systems. So the next thing I'm going to do is I need to tell all my interfaces. So now let's tell all the interfaces that you guys are going to do 802.1q trunking. So that way I'll be able to assign its respective logical units into the logical systems. So let's do set interfaces, and I'm going to specify the interface range. Let's just call this trunk ports. Say member interface range G000 to G009, and then I'm going to say this range of port is going to do flexible VLAN tagging. There we go. Let's show pipeline compare. Let's do commit and quit. Right? Yeah. Okay. If I say show interfaces G starters. Okay. That's great. Let's go back into config, but now we are going to create our first logical system. Let's do edit logical systems. As you can see here, you need to specify a name, and that's going to be one. And inside here, we are going to assign interfaces. Let's say set interfaces loopback 0. As you can see here, the loopback will have the unit, the logical unit equal to the router name. So it's going to be .1 family inet address is going to be 10.1.1.1/32, and we are going to give it IPv6 address as well. Address 2000:1:1/64. Going to say set interfaces G001.100 VLAN-ID 100 family inet address. Here it is going to be 10.1.100.1, of course, /24, and its corresponding IPv6 address 2000:100:100:1/64. I'm going to do set interfaces G001.19, which is connected to router 9, VLAN-ID 19 family inet address 10.1.19.1/24, and its corresponding IPv6 address of 2001:19:19:1/64. Okay, so we're done on R1. Let's go back to the top and show pipeline compare. You see I have created a logical system R1, and inside that I have assigned a logical unit number 19 of gig001, and its corresponding IPv4 and IPv6 addresses here. I have done the same. I have added a unit 100, and there is the address, and of course the loopback address. Let's do commit and quit. Now, if you want to go to a specific logical system and see only the config that belongs to that logical system and its interface, what you need to do is say set CLI logical system. If you hit question mark, see a logical system name. So you're going to specify the name of the logical system. You see that? Now I am in the logical system R1. Let's do show route. You see that? This is my IPv4 routing table. And underneath is my route, my inet6.o table, which stores IPv6 routes. If I say show interfaces ters, I only see the interfaces that were assigned to that logical system. And only if I say show configuration type display set, it's only the config that belongs to the logical system R1. So let's go back to the main system. I'm going to say clear CLI logical system. I am back into the global system, and I am going to create the rest of the logical systems the same way I have done with R1, and you don't have to watch me do all that repetitive work. When I am done, I will come back and we will actually configure the OSPF and see how it works. Okay, so while I was configuring logical systems, I figured we might as well go to the global system and assign the interfaces to the logical system, and then you can go to a specific logical system and assign an IP address. So how do we do that? Let me show you. So here, again, let me expand this a little bit, and let's create the logical system R9. Okay, I'm going to say set logical systems R9, and I'm going to assign the interface back 0.9. I am not assigning an IP address, just the logical unit of the system of the interface. And then I'm going to assign gig00/9.19. It is going to be the VLAN ID of 19. Oops. Yeah, there we go. So watch this. I am going to commit this and quit, and then I am going to the R9 logical system. Set CLI logical system R9. If I say show interfaces ters here, what am I going to see? I am only going to see the gigi009 unit 19 and the loopback 0 unit 19 that I assigned previously. So let's go into edit on that specific logical system. I'm going to say set interface. If I hit a question mark, I only see two interfaces. So say start logic unit loopback 0 unit 9 family net address it's going to be 10.9.9.9/32, and I'm going to assign the specific IPv6 address. It's going to be 2000 colon 9 colon 9/64 mask, and then I'm going to do set interface GE009. Let's do it in the short term. Family INET address, it is going to be 10.1.19 .9/24, and its corresponding IPv6 address of 2001:19:19:9/64 mask. So I can compare to see that. Let's commit and quit. If I now say show interface history in that logical system, as you can see, I have my address, show route, table inet.0. This is my IPv4 table and my IPv6. There we go. Isn't this cool? Okay, so I'll go back and finish the rest and see you in a bit. Okay, so I have done putting in the base config, IP address assignment. Oops, it's been almost 20 minutes now. So let's just do the quick verification, and then I'm gonna have to break this video into maybe part 2 and part 3, see how it goes. So for example, let's do a quick ping. Let's say run ping. Let's ping from R1 to R2, R3, and R4 on this shared segment. See if we can accomplish that. So I'm going to say run ping 10.1.100.2. I'm going to start off by pinging R2. I'm going to specify I'm sourcing these packets from logical system, and if you do a question mark, you'll see all the logical systems are being listed here. So I'm going to source it from logical system R1, and you can see the pings are going. Can we do the same for R3? Yeah, I can reach there. What about R4? Yeah, that's cool. But you don't have to do this really, doing ping and then sourcing. Let's exit and let's go specifically into the logical system R1. Let's say set logical system. Oops, it's not logical system. You have to set CLI logical system R1, and now here I can freely issue my pings. Let's now ping R9 10.1.19.9. You see, I can reach R9, and 100 to I can reach my shared segment like I've shown you before. What about the IPv6 ping 2001:100:100:2? I can reach R2. I can reach R3 and I can reach R4. Show up. You can see my ARP entries. So let's just end it here, and in the subsequent next video we will start configuring OSPF and go through the the area types. And yeah, that's pretty much it. For now, I'm gonna have to sign off, and I will see you in the next video. Bye bye.